Hi folks, we're going to take a look at page 226, number 13. Okay, so here they're giving us that cosecant of some angle A is equal to the secant of the angle 0.75. Okay, and they tell us that A is in the second quadrant, so that means it lies between pi over 2 and pi, and they want us to find A to 2 decimal places. Okay, so again, as soon as we see cosecant equal to secant, sine equal to cosine, tan equal to cotangent, we should be thinking about correlated angles. Okay, so we just have to find the relationship that's going to work. Now here they did give us a big hint. They told us that A needed to be in the second quadrant. Okay, so let's draw ourselves a little picture here. Okay, so this is the angle we know. So I'm going to call this my theta, if I want to relate it back to the way we wrote our correlated identities. Okay, so I need to figure out what angle A needs to be. Now, since I am going to be working with a correlated identity, I know that it's going to be the angle that looks like this. It should be the angle pi over 2 plus theta if A is going to be in the second quadrant. But let's just make sure this all makes sense, because it's saying that the cosecant of A, which is in the second quadrant, is equal to the secant of this angle in the first quadrant. That does make sense, because since sine is positive in the second, so will cosecant, so it makes sense that it'll be equal to the secant of this angle in the first quadrant, since all the trig ratios are positive in the first quadrant. Okay, so that means that this angle A is going to be my angle pi over 2 plus theta. Okay, so what I'm doing here is I'm trying to relate these angles to the relationships between the angles in the co-function identities. Okay, so that means that A needs to be equal to pi over 2 plus theta, but I know that the theta I'm working with in this scenario is 0.75. Now here, while they are asking us to 2 decimal places, it'd be tempting to use our calculators, but if we had access to our calculators, we wouldn't be doing this to solve this problem. We'd just be, using our inverse, in this case here, inverse cos function to find the angle and then apply it into the cosecant. Okay, so what I'm going to do is I'm going to try to do this on the calculator. But it's not too bad, because I know that pi is equal to 3.14 more or less. Okay, and so pi over 2 is just going to be 3.14 divided by 2. And that's just approximately equal to, so half of 3 is 1.5, and half of 0.14 is 0.07. So this is about equal to 1.57. Okay, and so now A is approximately equal to 1.57 plus 0.75, so just add those up. 5 and 7 is 12, 5 and 7 is 12, plus 1 is 13, and 1 plus 0 plus another 1 is equal to 2.32. Do a quick check. It makes sense that this is in the second quadrant, since this is bigger than pi over 2, which is about, as we said, 1.57, but smaller than pi, which is 3.14. Okay, so just to do a quick recap here. Okay, again, as soon as you're seeing some kind of scenario, a sine equal to a cosine, a cosecant equal to a secant, you should be thinking that you're working with some co-related angle identity. Okay, in this case here, they specifically told us it needed to be in the second quadrant, so it made sense that we were working with pi over 2 plus theta. And again, just do your quick check, makes sense. Cosecant is positive in the second quadrant, so is secant. Okay, and then from there, just solve for A. Okay, that's it for this one.